There you go. So everybody should know that we are recording this so that you can see it later on YouTube.
And there's your fork.
Very good.
Okay. You're welcome. I love you.
All right, Charlie,
Come on, guys.
you have the floor.
Okay, very good. I was just listening to the background noise. I don't know who that is. It's either on Chris or someone, but not me. Had some dogs barking out back. But welcome everybody to TennaTalk, a journey of discovery about all things antenna. And today we're going to be discussing with Mr. Antenna Whisperer, Rudy Weideman, both podcast 4A and 4B, 4A being impedance matching and 4 being the driving the SimSmith. And then just to keep everybody really excited, next month is going to be podcast 5, and we'll be talking about nano VNA. And we all remember when Rudy came to the club and did his demonstrations with the nano VNA, and there has been a lot of callback for that. And this should be a very good month for that. So on that note, Rudy, I'm going to go ahead and stop my screen sharing.
Okay.
And I will bring you up as the spotlight for everyone. And then anybody can manage their own screens if they want to, but I'll put Rudy right in the middle there and everybody. So Mr. Weideman, take it away.
All right. Good evening. Thanks, Charlie. Thanks for the introduction. Good evening, everyone. So, so far, looks like we had about 50 people who saw 4 Bravo, and we had something like twice as many watch 4 Alpha. So I don't know whether it just was too close together or whether 4 Bravo was a little more daunting, put people to sleep, or maybe it's a cure for insomnia. I don't know. But in any case, so who here on the Zoom call has not seen both 4 Alpha and 4 Bravo? Anyone? Just raise your hand. Just wave or raise your hand. Although I can't see Chris's camera. So everybody has seen 4 Alpha and 4 Bravo then?
Yeah.
Okay, good. Great. That's perfect. So Charlie, I don't know if there are people knocking on the door. I'm assuming you're going to let them in.
Oh yeah, they're already in.
Great. Perfect. So let's see. How many more people have we got here now?
There's a total of 9 of us.
Oh, okay. Hey, Craig. Glad you could join us. And there's David. All right.
Hi from Alaska.
Hi from Las Vegas. Anyway, so gentlemen, let's do this. Let's answer any clarifying questions that you have that left you fuzzy or unclear, or you got gaps in your understanding of anything having to do with that we covered in 4 Alpha or 4 Bravo, because I want to try to, for everybody's sake, make sure everybody's on the same sheet of music, and I'll tell you why. I built this series in a specific sequence that leads up to the next step. It builds on the foundation, foundation on foundation. And the next video, the next talk will be Nano VNA. You'll see a whole bunch of stuff in the Nano VNA now that'll start to make sense. And you'll go, oh, that's what it's all about. I can actually do that. I can actually, oh, and all the lights will light up in your brain and you go, oh my goodness. So that's the general idea. So I'd like to try to field some clarifying questions. So let me throw it open. Who has a question that they would like answered on material covered on 4 Alpha, 4 Bravo? Anyone?
And don't forget, if you just want to raise your hand as a video, or if you want to use the reactions to raise your hand, one cute thing about doing it by reactions is you'll be pushed to the top of the screen where Rudy will see you right off the bat.
You get flagged
But
right
if
away.
you don't do that, just go ahead and speak up is the easiest thing.
Yep.
Yeah, Rudy, a question. Will it be the next episode that explains to us how to connect the nano VNA and connect it in to use that information on SimSmith?
Exactly.
Okay.
The Nano VNA one will be a pretty tight, comprehensive one. of everything you need to know to really get like, geez, at least 50–60% out of everything that Nano VNA can do, if not more so, including being able to upload S1P and S2P files into SimSmith and store them on your PC, as well as updating the firmware in the Nano VNA, which can be a very, very handy thing. Especially like SysJoint keeps their firmware pretty well current. So every few months it comes out with another version. It's pretty easy to do. So yes, the answer is yes.
Okay, thank you.
Rudy? Yeah.
Yes,
Yeah,
Steve.
I guess what I was wondering about, I didn't really do the exercises at the end, but I followed through the stuff you were doing, and you did a great job of explaining things. Now, the thing is, once you end up with some L's and C values, you know, is there going to be something later down the road where you're going to talk about, well, when you're working on an antenna, how do you actually implement those L's and C's? You know, you look in antenna books and they have different types of matching sections and things like that, you know. So I guess that's the thing. Are we going to be looking into the practical, if you want to call it that, practical application of this, where you actually see, well,
Okay.
if I need a certain amount of inductance and capacitance, how do I actually do that with a particular antenna? You know, that type of thing.
Okay. Well, let's talk about that for a second. It's a good question. All of this is meant to be as practical as possible, right? Solve real problems that are not exotic something. We're not trying to design, you know, transwarp drive here. So the whole point of 4 alpha was to explain how LC circuits work and how their different configurations work on the Smith chart, and how you drive around on either resistance circles or conductance circles on the other side, and how you can only follow those paths and what the rules are for those paths. But, and generally how to keep the L's and C's under control, to be able to inspect and see what kind of L's and C's you want to use. But the idea here is very simple. If you're designing traps, it's you can use it for designing traps, tank circuits, filters, bandpass filters, high pass, low pass filters, whatever. But even more simply than that, good example, for example, is the UNA. There was an example in 4 alpha, and then I kind of revisited it in 4 Bravo again, about the UNA and how you could go from 450 ohms with 0 reactance and go pretty straight almost to the sweet spot, 50 ohms, but not quite. And by adding that capacitor upstream, or on the rig side, I should say, okay, to be clear, on the rig side of the UNAN, you could then come down right to the 50 ohms pretty nicely. You can't do that necessarily in all cases, in which case you use an LC circuit. So Steve, I would encourage you, if you've got one of those little breadboards, those solderless breadboards, okay, find an inductor, get an inductor, even wind a little inductor. They're not hard to do on a toroid. On mix 43 and some capacitors, and mess with it. Try to do something with it. Try to build a filter, or try to do some matching. So let's say you have an antenna that is a 2-to-1 at a certain frequency in 20 meters, and your SimSmith tells you that you need an L and a C in this configuration of these values, and you got something fairly close, and you stick them in the appropriate configuration that you're used in SimSmith, and voila, your SimSmith should show you that it can bring it right in to pretty close to or right on tuning. So hopefully, Steve?
Yeah, okay, fine. Yeah, you just froze for a second there. It's probably my connection there. Blame it on Charlie, right?
No, he paused.
Okay.
He paused to all of us, so
Yeah, okay.
we can trust Cox in doing that.
Yeah, okay, thanks, Rudy. David?
The floor is yours, guys. Ask away.
So I have a question to follow on with Steve's question. I've seen little breadboards. And they have different components on them. And I'm guessing that you can build a LC circuit with that and then actually try it out. So going through the Smith chart, and it says you need this, is that to actually prove it and test it, or what's that device for?
Are you talking about the little square board with a whole bunch of circuits on it that you use for the
Yes.
Nano VNA?
Yes.
Hang on a
yes.
second. I have one right here. Let me see if I can grab it. Because then I can tell you the answer. The short answer is yes. You can actually use that with the little connectors, and you can actually hook it up into your Nano VNA and see the effects. And then you can grab a screenshot. And I think that's what you're talking about, right?
Yes.
This guy. Okay. Well, that's a
Right.
that's a great point. These are Smith charts. Let's see if I can. I hold this up in front of me so that the background doesn't try to override things.
Yeah.
So these are Smith charts. Okay. And yes, this is what you should see on your Smith chart on your Nano VNA. And if you did an S1P capture, you would capture that same effect of a low pass, high pass, band pass filter that are on here into your SimSmith, and then you could analyze it and play with it.
Yeah.
Exactly. Yeah.
Now, since you're having to configure the capacitor may have different values and the inductor may have different values, how do you get different values on that board?
Well, okay. So
Or do you
what
just
you
get
do-
close?
Okay. Let me reach over and get a different kind of show and tell. You have probably seen one of these things.
Little closer. Whoops.
Whoa.
That widened us out.
Just the breadboard.
Yeah, that's the breadboard.
just perforated holes with a breadboard.
No, this is a solderless breadboard. It's got
Yeah.
a whole bunch of contacts underneath.
Okay.
And if you need help with that, just give me a call. I can show you how easy it is
You
to hook
know,
up. But
Rudy, that brings up a very good point. Mike's actually got a great question about lab stations would be good for this type of thing. And I think I know in the past we've thought about doing that at one of the meetings or maybe an auxiliary meeting
Right.
of the club, and being able to present, what is a breadboard, how do you use it,
Okay.
and all of that. Not necessarily how to solder, but understanding what goes in it, and then just taking a resistor and a capacitor and showing what an RC network look like, filter
Yeah,
looks like, or an
I'll show you.
inductor and a capacitor.
that's a
Or
good
resistor.
idea. We could actually try doing that sometime. Let me look here somewhere in my junk box here.
Isn't it fun when they walk behind the screen?
They disappear like a
The,
ghost.
the magic of Zoom.
David Copperfield, Andy.
Yeah, absolutely. There's some really cool things you can do with this technology. And one of them is what Rudy's doing right now.
Okay, here we go. So here's another example for you, David. This is specifically for RF components. This is a little breadboard,
Ah,
okay?
yes.
And it's got two SMA connectors for in and out. And it's got a matrix of different ways that you can connect stuff on here. And I soldered in with wire wrap connectors, okay? So that I could literally just take little jumpers. I have little female jumpers that go over the top of these pins, and I can just jumper them across. So I can stuff L's and C's in here, and I can jumper them across from the backside, and then connect my Nano VNA in here and
Oh, yeah.
out there. So that's another nice little giz that comes as a kit.
So they have a number of capacitors in there, so you can choose a capacitor that's close to what your S1P file says you should
Nope,
put in?
this is a bare board with just SMA and some connectors on it.
Oh, okay.
Uh,
You
you
still
got-
have to furnish the parts.
That's
Yes.
right, exactly. And you can wind your own coils, like I said, it's pretty easy to do. And let me know if you guys think you want to have a session. Maybe we can do a live Zoom session. That'd be kind of fun, actually, on how to wind coils and how to test them with your Nano VNA live. All right, whether they be a choke, a balun, or an unon, or even a regular inductor for an LC circuit. We can build one in 10 minutes, test it, and show you to you live. Did you guys like that?
That'd be fun.
Okay,
I got a lot of nods heading, heads
Okay.
nodding,
nods heading. Yes, nods. All those nods.
nods heading.
Okay, great. Yeah. All right. Let me work on that. Let me put something together, and we'll do that. That'll be fun. But David, it's pretty easy to do once you've got some kind of a breadboard. But even the solderless breadboard, HF is relatively forgiving in terms of connectivity. When you get in real high frequency, it's not so forgiving. But if you get one of these breadboards, you can get them pretty cheap, like less than $10
Oh,
on Amazon.
I get 10 for 10.
Yeah, you can get the really big ones that have multiple of these. So for complex circuits, I once built a full symmetric auto tuner with like 26 relays on it and a Raspberry Pi driven and everything like this on a board about that big, all breadboard, and it worked. So it wasn't optimal. It's not going to be commercial grade, but it showed what worked and what didn't work. It just told me which way to go, what worked and what wasn't the right way to go. So and capacitors, there's a lot. You can get capacitor kits. Amazon has several different capacitor kits. And I would say get them from about 10 pico to 1,000 picofarad. You can get 3 kilovolt kits. They're little blue. I gave you one, David. They're little blue guys.
Yep, I found one in my wallet. I've been carrying it around for months.
Well,
You've been isolating yourself.
You can tune up your you can tune up your wallet with that. So so you can get it in a kit of a 10 of each kind of thing. And that's great. Then you can wind your own coil, get some Mix 43 little FT114s, which are only about this big around, and some 18 gauge magnet wire with a varnish.
Okay, we lost Rudy again.
There he is. He's
Yeah,
back.
he came back. Yeah, you're just that's twice now, Rudy, that you're cutting out, and it's your video and sound all at once. Yeah, it's a freezing, and it's
that's
sound that
interesting.
would be an internet connection.
Yeah.
Just so you know.
Okay.
Wiggle
But,
the connectors, Rudy. It's always the connectors.
Yeah.
Always connectors. Absolutely. Always the bloody connectors. Okay. So more questions, guys, or comments. What did you like? What didn't you like? Give me some feedback. What did you think of?
Rudy, I've got one big question. I've always wanted to work towards my doctorate in electrical engineering. When I finish with these podcasts, can I either that or can I pass the professional engineering test?
Well, I don't know about if you know how to wire up a breaker panel.
Yeah.
I don't know if I'm going to be teaching you that, but
Actually,
look,
I've done that already. So
for hams, okay, usually it's 80-20, right? We get 80% of everything you could possibly do in 20% of the time, and it's good enough. Good enough for
Yeah.
government work, as we like to say, because it's not commercial, it's not professional grade, it's not what it's meant to be. It's meant to learn, right? They're tools for you to learn how to empower yourself to be able to do more what you want to do with ham radio.
Yeah.
And that's the objective that I strive for in this series, in the TennaTalk series. So if you have other topics you want to hear about, or you want to go into more depth on something, I'm all ears. Let me know. So more questions? Anyone?
Yeah, Rudy, I got a question.
Yeah, Ron.
I have a problem, and I'm wondering if SimSmith can help me solve it. My problem is my I've got one of those T-bias networks where you can put 12 volts on your coax.
Bias T.
And I discovered just a while back that it is introducing a significant SWR. And
Okay.
I don't know why, because I discovered it because the SWR meter on the 7300 was not agreeing with the external SWR meter just before the antenna. And so what I did is I put a dummy load on the instead of an antenna, and I got a fairly high SWR. And when I got rid of the T-bias network, the SWR went to 1. So I'm wondering,
Okay.
is there some way that SimSmith would help me figure out how to cure that high SWR from my T-bias network?
Okay, well, the first thing I would check are your connections. I would suspect that somewhere in there you've got a bad connector or connection, either a cold solder joint, a loose bolt that's holding some ground down or something like that. It's usually something done stupid simple. Have the bias T, because they come in pairs, right? You have to inject the
Right.
DC and you have to extract the DC on the other end.
Right.
Has that pair ever worked for you before?
Well, it works fine. It just introduces a SWR into my
Right.
antenna circuit.
Has it ever worked in a way where it did not introduce that problem?
No. Well, I just now discovered the problem.
Okay, so this is the first time you actually realized there may have been a problem from day one.
Exactly.
Okay.
I mean, it's
Well,
a
like-
homebrew network. I copied a schematic out of an old QST magazine
Okay,
and built it from that.
okay,
Everything seemed to work until just recently I discovered it's introducing an SWR into my
Okay.
antenna circuit.
all right. So, well, here's one thing you can do is you've got a nano VNA.
Mhm.
Run a nano VNA scan over the HF band on what you are getting, okay, and why you're getting an SWR of what? What's generating the SWR? Is it a low resistance or is it a high resistance? Because either one will give you the same SWR, okay, with a same given reactance. So find that out first, because it'll tell you whether you've got something that's going open or going short. So that's the first thing, is to use your nano to do that. You don't necessarily need SimSmith. SimSmith is really meant to find and to design a solution, an LC circuit or some a resonant circuit solution to an RF signal. Okay, a low pass filter, a trap on a dipole for a multiband dipole, that sort of thing, for designing and testing that. But for you, I just do an S1P or run the nano VNA. And if you want, sure, you can take an S1P snapshot, bring it into SimSmith and analyze it further there. But that would be my suspicion, because it'll tell you right off the bat whether you're heading more towards a short or more towards an open. And that could give you some clues when you open up the box and you go, oh, wiggle that around and it's kind of loose.
Gotcha. Okay, thank you very much.
Yeah, one
I've got
more tip for you, Ron, is take a look at the schematics, the MFJ schematics for their bias Ts. They actually publish the schematics, and make sure you haven't gotten something swizzled in there. Okay,
Right.
because it's very easy to get the L and the C reversed, and it'll make a huge difference, as you know. Okay, you're going the wrong way on the Smith chart.
Yeah, right.
So make sure you didn't get the L's and C's swizzled, and use it as a sanity check. So, Charlie, you had something you were going to say?
I'm just kind of curious, Ron, what are you using the T-bias for?
Oh, at my antenna, I have a relay where I can switch from the 40 meter vertical to the other one, and it's a 12 volt relay.
Yeah, and yeah, and I have a feeling it's exactly what Rudy's saying, is that will, if you've got a short or something, and you won't notice it because you're 12 volts, you've got probably a lot of variance on that relay to be able to work. So that's working, but it may be, when it's working, it's also adding a current into your antenna.
Mhm.
And that's what's blowing that off. And that would probably, and you're right, as Rudy says, that the Smith, when you run that nano VNA, get a Smith chart on that, and you'll see whether it's resistance or it's capacitance or impedance that's causing the SWR to go off.
Gotcha. Okay, thank you so much.
Okay. Other questions, other comments? Okay, well, let me share with you guys something that did come up that seemed to be a little fuzzy for some people. And I know for myself, it took me a little bit to try to keep all this straight in my head. But once you understand the basic map or principle of this thing, it'll be a lot clearer. So let me just share my screen here. Oops, hold on. Got to hit the right button, you know. Okay. So can you see that?
No, you're not sharing yet.
Oh, bingo.
There, it's coming in now. Let's see what it looks like. Oh,
Okay. Let me, yeah. Let me just zoom through all this stuff. Whoops.
went too far.
Yep. Okay. So the little red dot, that's part of the video.
Yeah,
So what I want to point out here though is you see these 6 variables in the whole concept of inductance matching: resistance, reactance, impedance, conductance, susceptance, admittance. Those get really confusing really quickly, and it doesn't have to be that way. You're going to see this over and over and over again in anything when it comes to impedance. And let me just explain. You probably are familiar with resistance or reactance. That's the 50 ohms plus JX, J 25 ohms, right? That's your Smith chart mapping. And the sum of those two is the impedance, or Z. And you can see it right over here. Z is equal to R plus or minus JX. And other 3, conductance, susceptance, and admittance, are simply the left half of your Smith chart, the other side. Okay, and the conductance is the blue conductance circle that comes from the 9 o'clock position, okay? And they bubble outwards towards the right-hand side. Those are the circles that you go up or down, clockwise or counterclockwise, with an L or a C. Susceptance is just the allowance of AC signal as opposed to the impeding of the AC signals. Hang on, there we go. And admittance is just the sum of conductance and susceptance. So it's written usually like a Y, and G is the conductance and B is the susceptance. It's just conventions. Why they named them that way, I don't know, but it's convention. And as you may recall, that Y is the inverse of impedance. So just think of it this way: resistance, conductance. Well, conductance is the opposite of resistance. It allows the passage of current. Reactance, well, the opposite of reactance is susceptance, which allows the AC signal. And the total reactance, okay, the impedance, total resistance plus reactance, okay, the inverse of that is admittance. So, you've got this in the video. You can go back and review it, but I just want to make it clear why these things come up. The last 3 are just dealing with the blue circles on the left-hand side of the Smith chart, and the top 3 are just dealing with the red circles on the coming out of the 3 o'clock side of the Smith chart. That's all this really means. Okay, were there any other slides or things you want to see done with SimSmith? I've got SimSmith up and running right now.
It just takes a while to absorb all this stuff, Rudy.
I can agree. It takes a long time to have prepared all this stuff. My rule is about 10 hours to every hour on the air. And so this one took a little bit longer than that because it is, it's funny. It's a little like ice. It's really hard at first, but once you crack it, it's pretty easy to put your hand through and reach through it and grab stuff, okay, on the other side of the ice.
What I think is amazing is all the stuff it will do. The Smith chart will do, because like I mentioned, I downloaded the manual, I printed it out, and it's 242 pages long.
Yep.
So,
Oh,
holy cow.
it's really cool. You can design, they have a schematic editor in there. You can just draw your own little circuits with L's and C's and resistors and transformers and
Mhm.
anything you can imagine, and literally shove it into SimSmith and run signals through it and analyze it and see what comes out the other end and see what you can do with it. So it's a great model. The trifecta that we will eventually get to is SimSmith, the NanoVNA, and EasyNet. EasyNet is the modeling program, because you take EasyNet and you say, you know, I want to build a new kind of, trap dipole. And I haven't seen one that's exactly this way, that's short. I want to see if I can build a trap dipole. You build it with EasyNet, you model it. You literally, that can go straight into SimSmith by default. SimSmith brings it up, says, oh yeah, here's how it'll perform, and here's a couple things you could do to tweak it a little bit, and you can go back and forth. And then when you build it, you take a shot of it, an S1P file snapshot in your NanoVNA, import that into SimSmith and see how close you got. So it's really a very, very powerful trifecta, that triangle of EasyNet, SimSmith, and NanoVNA, and that's, we'll be getting to that pretty quickly here now. Then doing the NanoVNA and EasyNet is actually a little bit easier to swallow and to comprehend than what we've gone through on 4 Alpha and 4 Bravo. This is the hard stuff. This is the foundational stuff that you really need to kind of try to pay attention to if you really, really want to understand how to deal with antennas and tune antennas, or try to fix antennas, right? You got an antenna that's just not getting below a certain SWR. What can you do? And sometimes you have to resort to some kind of a LC circuit.
Yep.
So good. Was there anything on SimSmith that you guys want to see? You want to see me do? I've got it. Do you see that? I think you should be seeing that.
Mhm.
That is correct.
Okay. So I got SimSmith hiding underneath the PowerPoint. So like I was saying, that you can build just all kinds of stuff with this, and you can do multiple sweeps with. I mean, I haven't shown you 80% of what SimSmith can do, just the top 20%. We just hit the very highlights of it. You can run Monte Carlo analysis and try to find out how many different solutions I can have with standard L's and C's that you can buy off the shelf, and it'll plot them. Every combination perturbation, it'll plot the solution up on SimSmith, and so you can run sensitivity analysis on stuff. So it's like I said, it's an incredibly cool and powerful program.
Rudy, a question?
Yeah.
For instance, if you wanted to build a low pass filter, exactly how do you get started using, you design, say, I want a low pass filter and I want the cutoff frequency to be 33 megahertz. So where would I start?
Okay. Well, you start with your generator, okay, and you design where you want to have your inspection frequency, okay, in terms of megahertz.
Mhm.
What you're looking at right here is actually a low pass filter. It's
That is correct.
it's a classic low pass filter, and so
Yeah, that's a 40 meter.
exactly. Well, this is an auto tuner block. If I really wanted to, what I would do is I would drag him down here, and because it's trying to auto tune for you. What I would do is I would drag this up here,
Oh, there you go.
and I would drag that up there. And then what I would do is I would see, I can do a variety of plots here. Like you can on your NanoVNA, you can do a log mag plot. And, right now, it's been a while since I've done that round, but I know you can do log mag plots of for exactly what you're talking about. And you run a log mag plot to see what what will pass from your generator to your load. And instead of right now, we've got one frequency and we've got one set of criteria here. And you can literally do a scan that's a log mag plot. But like I said, you can, I think there's some examples of this in the SimSmith manual itself. If not, there's stuff online, a lot of support for SimSmith. And in fact, the AE6TY, Harriman has actually built a bunch of videos on YouTube that go into SimSmith in much greater detail than I did. I just kind of did a quick foundation for everybody to get you at least hopefully to the point where you want to play with it.
Mhm.
So
It is fascinating, that's for sure.
yeah,
Rudy,
yeah,
I was gonna ask you, like, when you look in the lower left-hand corner where they show the different L's and C's and this and that, like on the second row down, it looks like that's like coax there, right?
They
So,
are.
like,
It is.
yeah, so you
that's
can
exactly right. So let's throw
look
that in
at
here.
quarter wave, I mean, like opens, shorts, that type of
So
thing.
let's do that. So this is the list of all the different types of coax that are whose characteristics are already pre-built into SimSmith.
Oh,
And they've
okay.
got a
Wow.
variety of RG8X. They got a variety of LMRs. They got a variety of of all kind of ladder lines.
Yeah.
Okay, so
Wow.
for example, let's see here, 50 ohm, 50 ohm. Somewhere in here, they've got, oh, there it is, 400, some 400 ohm. There's some 400 ohm ladder line.
Mhm.
Anyway, so they've got, yes, a whole bunch of different defined stuff. So let's find some RG8X. I just saw it.
Yeah,
All
right.
right there. So let's put that in there and then pick the feet and say 50 feet of RG8X. And what's really cool is you can actually see, and this, we're not tuning anything worth a darn here, so don't worry about the performance. But at each stage, as we go from the generator through each block, remember every interface, you want an impedance match, okay?
Mhm.
And it'll actually tell you the degradation in watt throughput, efficiency throughput, okay, from step to step to step. So if, for example, I pull this out of here and I pull this out of here and I put an auto tuner in there in its place so that I know that it is
Pull that up.
it's going to be in tune. All right. Now I can see the degradation from 1 watt into my coax. It's 91% efficient going into the tuner and 47% efficient into the antenna, into
Yeah.
the load.
Yeah, because your SWR went from 25 to 1.0.
Right, exactly. So this will actually give you lots of capabilities. Like I said, once you start importing stuff from your Nano VNA into SimSmith and start playing around. And by the way, for those of you guys, I think most of you actually had an antenna at the shootout. I will send you your S1P files that I captured. And then you can just literally drag them and drop them from your desktop right over here to the word file where it says none. Just literally drag it onto the word none, and it'll go into that block and it'll inject that S1P file as though that were the generator. Okay, that's what was coming out of your, coming back from your antenna. So it's very cool. It'll give you some fun stuff to play with. You can tweak it up, put the auto tuner there and tweak up your antenna for different bands, for example. You can do that. See if you can push it around and retune your antenna for a different band with a reasonable capacitor and inductor and not one that is so humongous or so ridiculous. It would be too big to build.
So Rudy, once again, when you say that S1P file, I'm not too familiar with that, but like for the antennas we used at the shootout. So that shows you what your antenna looks like at different frequencies. In other words, you're saying, right?
Correct.
Oh, okay, yeah, no, that would be interesting, so.
It's what it is, Steve. It is the scan of your antenna from the starting to the ending frequencies of your stimulus range, and it captures X number of those points. And those points are encoded, are the impedance, but they're encoded. If you ever look, it's a text file. You can open it up and read it as a text file. If you look at the text file, they won't look like impedance R plus JX. They won't look like that. There'll be a frequency and there'll be some other numbers behind it you won't recognize. Those are actually S parameters, or what's called scattering parameters. Those are what network engineers use to look at, to diagnose signals, okay? Inputs and outputs in terms of networks and input port, output port, that sort of thing. But the good news is SimSmith knows that. And when you drag and drop it in, it automatically turns that into an impedance sweep on your screen on SimSmith.
Yeah, yeah, that will be interesting to see.
Okay, what else, guys? So you guys are all experts on, you guys are all experts on 4 Alpha and 4 Bravo now, right?
You got us very interested, that's for sure.
Good.
I will have to say one thing, Rudy, is if I would have had SimSmith and everything else when I was going through college, it would have made life a lot easier, to tell you the
yeah.
truth. Of course, that was what, 40, 50 years ago. So yeah, 50 years ago. Holy crap. But I want to tell you, the way you've explained this is exceptionally well.
Thank you.
Kudos go to you, sir. Excellent. In fact, actually, have you ever thought about entertaining going to work over at UNLV's electrical engineering department? Because some of the guys over there can't even do this. So,
Well, you know, knowing just because you're an expert in the material, technical material, doesn't make you a good teacher, and vice versa, right?
well, if you do PowerPoints for them, I'm sure that they'll come through, because these were very, very good.
Thank you. It's a lot of work to both understand and convey the raw technical material, and to present it in a way that people can digest and absorb and actually use. And when you get all three, the SimSmith, Nano VNA, and EasyNet under your belt, suddenly you're going to say, wow, I can do all kinds of cool new stuff. I can design antennas. I can troubleshoot my antenna. I can troubleshoot RF circuits, okay, just by taking an Nano VNA shot and bringing it into SimSmith. So there's, like I said, it a whole new level, a major level up above, step above, is what this will bring you to. And that's the objective here, is to get you to a completely new level of capabilities. It's like having a 26-piece Swiss Army knife, and having to operate just one item. That's the knife, right? And you carry around this huge thing with you, and you've never used the other stuff. Well, this is the other stuff. These are all the other tools that you can use in the Swiss Army knife called impedance matching.
Very good.
Good. Anybody else? David, Mike, you've been kind of quiet there. Don't be shy. Speak up if you have any questions, comments, whatever.
I'm still trying to figure out how to order the waffle board.
Oh, actually, I can probably help you with that, Mike. There's quite a few of them out there, and Amazon's got some. But then if you just search on the internet, there are some companies that have kits and everything that come with them that make it a lot easier to understand what you plug in and everything. They, some of them come in with resistors and capacitors already in a kit, and it works out pretty good. Amazon's got those, as well as some of the, if you go to AliExpress, they have them for sure. That's where I've gotten most of mine. And that's yeah.
I will share something with you, Mike, that I've recommended to several friends who wanted to mess around with it, and they've had great success with this. I don't know if you can see, can you see my screen, Steve?
Yes, we can see it.
Not sure. Something else.
We're going to your Amazon page. I see that.
Yeah, that's where I want to
You
go.
know, there's a couple other too, and I'm going to say this wrong. Is it Jensen Electronics
Heard of that. Yeah.
or God? I can't remember. Oh yeah, there you go, Rudy.
Okay, that's my recommendation for
Yeah.
50 bucks. You
Yeah.
get, there's the board down here.
Yeah.
Okay, zoom in here a little bit, the breadboard. And this kit was actually meant to be an accessory kit for interfacing with a Raspberry Pi, which, by the way, if you want to know all about Raspberry Pi, I used to teach Raspberry Pis to 10-year-olds.
Really?
And really. And so
Teach me how
the,
to get one that isn't $400 or $500 right now.
actually, yeah,
Are they coming
they're
around now?
They're more expensive than they used to be, but they're still relatively affordable. But what you can do with them is really cool. But to answer your question, Mike, you've got a whole bunch of LEDs, you've got a whole bunch of resistors.
Yeah.
Okay. Now, granted, these are not as wide ranging and you don't have any inductors or capacitors in here. These are mostly for interfacing, but you'll get the breadboard, but you can go on Amazon and just look up solderless breadboard. And you'll get something of a variety of sizes. The other one is Adafruit. Adafruit is a great place for finding this stuff, but not for RF stuff particularly, just mostly again for Raspberry Pi. But they have a whole bunch of different types of bread. But if you just Google or go to Amazon and go to the solderless breadboard, they're really pretty handy to have when you want to prototype something. But like I said, I did find out something very interesting back to impedance matching and nano VNAs. Do you guys remember at the shootout, I had my iPad running, was showing reverse beacon network, the hits that we were getting on reverse beacon network?
Mhm.
Well, I did that by actually sharing my desktop from my Microsoft Surface tablet, sharing it through my phone as a hotspot to the iPad. Well, guess what? The Raspberry Pi can do the same thing. It actually has a facility to share basically its desktop, all right? And there is a version of Nano VNA Saver for the Raspberry Pi in Linux that you can run on the Raspberry and share the desktop to a tablet or a PC or something like this and remote that Nano VNA Saver onto another device wirelessly. So there's a cool application of Raspberry Pi for ham radio for Nano VNA. Any of you guys interested in Raspberry Pi for ham radio? Yes? No?
Oh, yeah.
Yep,
Okay.
yep.
You know, Rudy, that we use Raspberry Pi on our controllers now for our repeaters.
Really?
Yes.
Okay. Cool.
I have two All-Star nodes from Raspberry Pis.
Yes, that's exactly right.
Cool. Well, what I do is I teach people how to use Node-RED, where you can do 80% of everything you want to do without writing a single line of code.
I want to
How
learn.
about that?
I want to learn Node-RED.
Was that you, Mike, saying that?
No, that was Chris.
Chris,
Oh,
I know
Chris.
70.
Chris,
Yes,
speak up. What were you saying?
I said I want to learn Node-RED. I've heard so much about it. I just haven't really done anything with it. But I've got like 4 Raspberry Pis around here that aren't doing anything right now.
Okay. Well, like I said, I used to teach how to build. As a matter of fact, I'll do you one better. If you go to YouTube, there's a series, a 7-video series called, I'll try to bring it up here real quick, called Steampunks, STEAM, for science, technology, engineering, arts, and math. All right, I threw the arts in there because I think it's fun to do LED projects and control magnets and other fun stuff flying around. Let me find it right now, and I'll show you what to look for. Hang on a second. All right. And it's called Code Free IoT. literally code free IoT. And it's on YouTube. It's a 7-video series and it'll actually walk you through step by step, Chris. Okay, let me, Raspberry Rudy, yeah. So sometimes I'm the antenna whisperer, sometimes I'm Raspberry Rudy. Anyway, I built this a couple of years ago, and there's a series of 7 videos, and each one about 20-30 minutes or so. And so Chris, this will take you through to the point where with one of those Freenode kits, those Freenode Ultimate kits on Amazon, and in fact, I even pointed out in the video what to get. It's the same kit. That and your Raspberry Pi, you're off and running. Just follow along, and you can do it. It's fun. It's not that hard.
I'll definitely play with it. I'm a Linux geek anyway, so.
Oh, okay. Well, you don't need to be a Linux geek. You, like I said, you do it with the whole thing about this was not writing a single line of code if you didn't want to.
I will definitely check it out. Thank you.
Cool. All right, so there's a plug for one of my other YouTube channels. You didn't know I had another YouTube channel. So, okay. What else, guys? What else can I answer in antenna impedance matching, SimSmith, and all of that jazz?
In SimSmith, there's on the menu bar, there's something called running, and you can cancel it and or stop it or abort it. When you're using it, why would you not do it live? I'm not sure how to use those buttons.
So David, that's when you're doing really, really complex stuff with a lot of variables in it. For example, you've got a complex custom circuit that you designed a schematic for, and it takes a long time for it to crunch through and analyze that. And suddenly you go, oh, I made a mistake. I shouldn't have launched it. You want to just basically abort the process. This allows you to do it.
Okay, so it probably takes a while. So you would, in the case of how complex it was, you would stop it, build it, run it.
In your case, you probably never even run into that.
Okay, so just keep it
for a long time. Yeah, for a long time, you just let it run live. Let it free run, and it'll do its thing instantly.
That makes sense. Thank you.
Cool. So what else can I show you guys? Is there anything you want to see me do with SimSmith? Some backflips?
Well, I think it's done pretty good. I think we've got the audience narrowed down and going forward. So what is next month is the Nano VNA, right, Rudy?
Correct.
Okay, well, we're looking for that. We will definitely be looking for that. So we've got, I think we can give them back 7 minutes of their time.
Can I ask one more quick question?
Sure, go ahead, David.
For Rudy, what is the format you plan to use in the Q&A with the VNA? Are you going to do it as something interactive, like a workshop on Zoom, or I don't even know how you would do that? Everybody's probably got a little different VNA, where the menus are a little different. That's going to be kind of like herding cats around the park. What's your plan?
Okay, well, I've been toying with the idea of doing something similar on 5 Alpha and 5 Bravo, splitting it up, doing a quick 30-minute 5 Alpha on demonstrating, not a PowerPoint per se, but just demonstrating how to set it up, how to configure it, calibrate it, all the basic things, how to get it useful and functional, and what all the menus do, where they're at typically, how it's typically organized, and what they typically do, what to recognize. Okay, recognizing the verbiage that they use, like stimulus, what's that, right? And then how to calibrate, of course, very important. Then to actually do another one, doing an actual live demonstration of several typical cases of being able to analyze an antenna, take an S1P file, export it, bring it into SimSmith, bring it into NanoVNA Saver, or actually, NanoVNA Saver talks to the NanoVNA real time through the USB bus. So you're actually seeing live on NanoVNA Saver, and you can save it then into your PC directly through NanoVNA Saver instead of having to upload it from a capture in the VNA itself and then plug it in and upload it into the PC. NanoVNA Saver eliminates all that. You're live in Nano. Everything you're seeing in NanoVNA Saver is already live from the NanoVNA. So I think maybe that's what I'll do is I'll do some demonstrations and make that a live demo as a second part of that.
Okay.
And just to answer your question, one more thing, David. I know you mentioned that not every NanoVNA and every menu is exactly the same, but trust me, once you have the basics down, you'll recognize 80% of the commonality factors that they all share, and you'll pick it up pretty quickly, even though you have a different nano.
Okay. Do you know if anybody has created a menu path with, well, hopefully the type F that allows you to, that what it came with was an illustration of the menuing system. And I'm thinking to do one function of the NanoVNA, taking a blue highlighter and go across the menuing system, the menus, and kind of put colors in so I know where I'm the path I need to take to do what I need to do. I mean, there's lots of things that the NanoVNA does that potentially I could put different color codes on the menu. And I mean, it's just a piece of paper and it shows you the flow. Is there anything that's pre-done for that?
Not that I know of, not in terms of typical examples of paths you would take through the menu to achieve certain things. I will tell you that by the time you went through that exercise, you would know the NanoVNA menu well enough. You don't need it.
Yeah,
I know a lot of guys, David. Yeah, a lot of
Pardon me?
guys have taken their NanoVNA and taken that thing and make separate sheets for specifically what they constantly do, like when they're testing their antenna for SWR, just that. Or if you're tuning, I know that there was one guy somewhere that wrote up exactly how to use it to tune a repeaters to tuners. So that, that is one thing that, can be done, but it just depends on the way you're going through it. But you're right. You've got to, there are so many options when you hit one and then go to the next, go to the next. I like the idea of what you just said about using highlighters to highlight what you want to do. That would work. Absolutely. Just make a bunch of copies of that sheet. Do it for each one.
Yeah.
Yeah,
Well,
I may have to go that way. I just kind of wanted to cheat and follow somebody else's lead on that.
Yeah. Like I said, David, by the time you've done with that exercise, you will know more about how to do it, and you probably won't need that crutch anymore. But it's not a bad thing to do to actually really learn it yourself and be comfortable with that path. Like calibration, you're going to be doing lots of calibration. Okay, so that should come. You should be able to do that in your sleep. Couple other cool things that the NanoVNA can do, by the way, is the latest software has actually an LC solver in it. It'll actually tell you the values and the LC configuration you need to solve at that frequency, solve the circuit for the minimum SWR at that frequency, which is really pretty cool. Yeah,
that is cool.
I didn't know that.
Yeah, and I'll try to show that as part of the NanoVNA thing. It is pretty cool.
Well, we're at the top of the hour, Rudy. You have done another great Q&A session on your podcast, and I want to thank everybody for joining. And tell your friends and neighbors, and maybe I'll see some of you guys at Saturday's Science and Technology Festival, which, by the way, is getting bigger and bigger every year and a lot of fun. You'll see a lot of robots there. Talk about seeing electronics, David. There's one place if you want to see it. And so thank you very much, Rudy. It is a pleasure, and we'll see everybody after they do their studyings for podcast 5, and see everybody on the first Monday of June. So
Yeah, and we'll see you in Amargosa in a couple of weeks.
absolutely, you are right, Greg. That's going to be fun.
It will.
I'm going to pack my cooler just in case. No. Very good. Thank you,
All right,
everybody.
guys,
Have a
Thank
great
you.
week. Take care.
take care.
We'll see.
Bye-bye.
Bye, Rudy.